there's a crater on the moon named after him, and he was Iranian or Persian. I guess you would say Persian back in his day, right? So these people are important if they're written down in history and remembered for this long.
Oh, that's one thing, Hank. But is his measurement the only measurement that's ever been made of the Earth? That's another thing. And my question is that likely to be true? And I think without even looking at any evidence, just knowing that this measurement was taken 1,000 years ago, I think that knowledge alone should be enough to make you go, hold on a minute, 1,000 years and nobody else has done it.
Well, I don't know if they could have done it. Someone could have done it and not wrote it down.
Well, that's what I'm talking about. It's 1,000 years and nobody else has done it and published it for for other people to see.
To run these experiments again, you need not high tech. You can do it with some sticks and strings or something, and you can do the measurements again.
Well, for it to last 1,000 fucking years, it must have been written down right.
Well, I'm not arguing that it has lasted 1,000 years, though. I'm arguing that it hasn't.
But
I'm arguing that since then, we've done it in many other ways, geodetic surveying and...
Yeah, we didn't have the technology back then to do it that way. So now we've only just got the technology in this last fucking, century. So,
I don't know, we were doing accurate geodetic measurements 300 years ago.
Yeah, accurate to within. Yeah, I mean, look at the fucking Egyptians. I was talking out my ass there, yeah. They're accurate to within fucking, a tenth of a fucking inch. So, they were doing it right back then. So.
You guys are shouting the shit out of me in the chat section there.
There were aligning fucking pyramids.
Hank likes Nathan to yell. I like Nathan to
Well, that's what happened, wasn't it? Like 3.5 years ago, I think Riley brought you up as a case study to Nathan to make his show harsher. I remember him mentioning that like
case study
10 times. Yeah, that's what happened.
Is that what I am? I'm a case study.
Al-Baruni was
in this particular situation.
He was probably an Arab or something,
Al-Burundi was a NASA shill.
NASA shill. I think NASA would even fucking been
just up in smoke. It must be easy to Wicker Man the Hank Hill straw man.
Would you say that NASA was around fucking 20,000 years ago? I doubt it.
Well, somebody wrote this in your chat.
Some erased person that needs erasing quantumly, yeah.
So somebody wrote Hank's a twat. They're probably right. They're probably correct.
Well, only in the mind of a fucking cartoon developer, but you get it.
Where is everyone today? Sorry, go on.
What day is it?
What about the Bolivian salt flats?
What about
them? And the other salt flats?
Oh, it's Friday. That's why it's dead.
It's not Friday yet.
Well,
Friday night. Sorry, it's Friday morning.
Yeah, it's Friday morning here. So, but we're 9 hours in front of you, so you must be somewhere around LA.
So, I would like to quote somebody known as John Stunja. So it's Modus Tollens. I bet you guys haven't heard this before. What do you want to bet?
Well, we've heard every word you've said about it so far, but okay. Go ahead.
If P, then Q, not Q, therefore not P. If the Earth's sphere with a radius of 3959 miles P, there must be a measurable 781 meters of vertical drop every 100-kilometer section of the Earth traversed. With a salt flat, we don't see that, so therefore the Earth's not a sphere. What do you guys think?
I think that's true if you pretend there's no such thing as refraction. Why are you doing that?
Well, refraction does happen, but does it happen at the same rate as the Earth curvature?
Why doesn't it?
Well, it can do.
Some can make it do that.
Whether it can or not is kind of irrelevant because you've just ignored it.
No, I didn't ignore it.
You did.
I'm actually
Okay, where in your claim, where in your if P then Q did you fit refraction?
okay. Hold on just a second. Let me go to this Oxford Journals.
Well, the sun swings around, so it's obviously going to want it, you know.
All right, so posted the Oxford Journals, and I guess they don't mention the refraction. They just outright say that there's no curvature. So maybe the people at Oxford haven't heard of refraction. You might want to phone them up and tell them about this refraction where the light bends around the Earth's surface at 8 inches per mile squared for 9,000 miles. Kilometers.
Other words, there is no curvature in this.
So if you read it and use a little reading comprehension and
But he asked you a question.
right,
No, because I think
actually
they're
say
talking-
that. It
Well-
doesn't actually say that word for word. If you'll just let me go over it real fast. Report. Let's see.
You're answering his question.
It doesn't actually say that. Did you hear me say that? I said that like just a second ago.
It's not like diverting over somewhere else about
But
something
this
else.
is talking about how much an area differs from sea level.
Less than 1 meter of vertical relief over 9,000 kilometers. Is that almost the same thing? Is that synonymous with saying there's no curvature?
No,
Less than 1 meter of what's
No.
vertical relief?
Exactly.
You guys know what
that would be true of any ocean, wouldn't it?
Yeah, because water's flat.
Well, but we would, from this side of the argument, we would make that description in exactly the same way of a equally sized piece of ocean.
Well, yeah, because water's flat, just like the salt flat.
Right, but the claim is that the Earth is curved, that water's curved, right?
Well, that's your claim.
Yes, and our claim would also be what you've just said, but about water.
Okay. Well, these guys
And so we would say all those words that you just said about a piece of water, and we would still say it curves around the Earth.
Okay. So
Because sea level is 0 all around the Earth, but we still say the ocean curves around the Earth, right?
yeah,
So you go
right.
from one. If you're in the ocean and you're at sea level, you're at a 0 elevation. If you travel 900 kilometers or whatever figure you gave, you're still going to be at 0, and you'll have been at 0 all along the way, right? So you're just conflating elevation with curvature.
No, I'm not, because
You are. This is a report about elevation. It's not a report about curvature. These people are what? So you think that these people have just accidentally slipped up and put a paper here that says the Earth's flat,
No,
and they're
telling the truth.
they just fucked up and didn't realise.
No. They got it. They nailed it. See,
I've been published.
less than 1 meter of vertical relief. So vertical, right? We know what that means.
Yeah, elevation above sea level.
And then what is relief?
It means, that's how we describe
Like terrain, right?
Yeah, the
Terrain
contours
or
of the land.
relief.
We call it relief, right?
Topographical relief, right? So
How many
what is-
mountains and valleys there are there? That's what that is a measurement of. We aren't arguing that there are no mountains and valleys, are we?
Right, so it's perfectly flat because there's no mountains or valleys.
Right, but not curved. There are no mountains and valleys on the ocean, are there? But
No.
we don't, when we say that it's 0 elevation everywhere, we aren't saying it's not curved.
So I just looked up terrain, right, which is the same as relief. Those are synonymous. And the Wikipedia says relief or local relief refers to specifically the quantitative measurement of vertical elevation change in a landscape. So
Right.
like you said, it doesn't curve up or it doesn't go down. There's no mountains, no valleys. It's perfectly flat.
Elevation change isn't a measure of curvature, is it? Elevation is a measurement of distance above the surface of the Earth. It's a distance from sea level.
I don't think we're going to get too much further on this conversation, so we're going to have to agree to disagree.
Well,
So,
you could. I mean, I don't really get how you. I don't see how you can believe that this paper is telling you that the Earth's flat.
no, it's telling
You
me
do understand. You do understand. There's a distinction between elevation and curvature, right? You understand.
Well, in your mind there is, but the way I understand it, and
in the model that's presented, I'm talking
Q rumpus, the way I understand it is that it's saying that the salt flat is perfectly flat. It doesn't say anything about sea level. You just invented that.
Well, it does. It specifically does say that.
Don't you get like a rumpus soundboard where he says, "I don't understand" after I disagree with you?
Well, it's talking about what was the actual words it used for measurement of relief, right?
Vertical relief.
Yeah, vertical relief. That's it. Well, that's a measurement from sea level by definition.
I'll look it up, see if I can find anything about sea level.
Well, how do we measure? What do we measure when we say a mountain is 29,000 feet high? What from where? What are we talking about?
The bottom of the mountain.
Right, and what's the bottom of the mountain? How do we define that?
Wherever the mountain starts.
Right, well, what would the elevation be at that point?
It depends on where the mountain's at. I mean, if it's a mountain in Texas, it's going to be low, like 700 feet above sea level. But if it's a mountain in Colorado, then it's going to be like a mile high.
So you've got a mountain that's in a 700-foot canyon, 700-foot deep canyon.
Well, that's how high I am above sea level. I'd imagine that if you go to West Texas, where the mountains actually are, it might be a little higher. I don't actually know how high they are.
But when we say how high something is, where are we calculating that from?
From the ground.
Right, but we have to be starting at zero, right?
Not from the sea level, unless the mountain's coming out of the sea, like Hawaii or something. But even then, it's
so. What you're saying is, if there's a mountain here in Britain, and I say it's 10,000 feet high, and you've got a mountain in America that's 10,000 feet high, if we put them side by side, they could be completely different sizes.
Exactly. Depending on
that's what you think is you think that the elevations around the world are just arbitrary.
No, that's not what I said.
So we can't a mountain climber who knows he's going to 10,000 feet in America, he could be doing something completely different if he does it somewhere else. Come on, Hank.
No, that's not what I'm saying. What I'm saying is that if there's a mountain in the U.S. and it's a mile above sea level, right? It could actually be a smaller mountain than, say, somewhere else that's, like an island, right?
Right.
And they measure it from the floor of the mountain to the top. They don't start at sea level.
How do you determine the floor of a mountain?
It's the foot of the mountain. I meant to say
how do you determine that?
Let's look it up. Let's see, how tall is Mount Everest?
29,000 feet.
I meant to say Rushmore. I'll go ahead and do Everest. Hold on. I'm so American. Okay, Mount Everest. All right, so it's 29,000 feet. All right, so let's see. Where is it located?
The Himalayas.
All right, let's see if I can get elevation. Maybe I need to word this differently. There it is. Sorry, I'm looking. Okay, so it rises only 13,796 feet above the sea level. So they don't count that as part of the mountain.
What does? Sorry.
Sorry, how many
That's-
kilometers is the question? How many kilometers is Mount Everest above sea level? It only rises 13,000 feet above sea level. So they're measuring it from the foot of the mountain to the top of the mountain. They don't actually measure it from the sea level to the top of the mountain because you could just cheat. Anyway, that's trivial. Doesn't matter.
Hold on a minute. That can't be true.
I mean, why would they measure to the sea? They would have to
Well, because measurements would be completely meaningless otherwise, wouldn't they?
Okay, so
If you measured everything from what you judged what somebody arbitrarily judged its bottom to be, how would you be able to compare the size of anything with anything else?
So Mount Everest is 29,000 feet. How tall is the mountains in Colorado? Because they get a mile head start.
How do they, though?
Because it's a mile high city in Denver.
Well, a mile high, though. A mile above what?
Sea level.
Right. It's always
14,000
above sea
feet.
level. All of these measurements are effectively from sea level, even if there's no sea present.
How to measure a mountain. Well, that didn't answer that question at all.
There has to be a starting point, doesn't there, for all of these measurements?
You would think it would be the bottom of the mountain.
Well, I wouldn't, because I don't think mountains have a bottom that you can point to and say this is the bottom.
Well, the foot. Like, if I stand on a chair, you're not going to measure me at 12 feet tall, right? You're going to start the tape measure at my foot.
Right, but you aren't attached to the earth, are you? If you were growing out of the earth, it wouldn't be so easy for me to judge, and you were mountain shaped. How would I judge where to start measuring from? What about something else, like a I'm trying to think.
Automata?
Well, just hills and valleys.
What about everybody else in the room? Do you think they measure from sea level to the top of the mountain to get the height of the mountain? I mean, I suppose you could, but
Well,
how would any measurement of a mountain be any? It just wouldn't have any meaning, would it?
yeah, because it'd be like cheating. If you use the bedrock plus the mountain to say, "Oh, my mountain's tall," but
Right, people would just arbitrarily decide where the mountain starts, wouldn't they?
yeah, so they got to measure from the foothills, the foot of the mountain.
No.
Okay, here we go. 15 tallest mountains in the world from base to peak.
Some could be below sea level, don't forget. Not all mountains start on the fucking surface. A lot of them can start below sea level.
Well, I actually doubt that that's true, if you think about it.
Well, I mean, if the mountain started like on land and then all of a sudden...
Right, but if it's on
water
land, it's
surrounded it-
already above sea level.
Yeah, and then water surrounded it, that means that it's gone below sea level now.
Well, I guess that's possible, but it seems unlikely.
It is possible. Bloody Ireland, Britain's an island, right? And there's water
Right,
around
but it doesn't have a big valley in the middle of it and then a mountain in the middle of the valley. That isn't how we usually... Mountains, usually what you do is you get land rising up and it gradually gets more, it rises more and more.
Yeah, I get you.
And then you get a mountain.
I'm just being
So
flippant, sorry.
we don't usually find them in the middle of holes.
No, we don't. But then again, if the world was flat, we don't usually find big holes in the bloody floor with space in the middle of them, do we? You can't look through the middle of the earth and see space, really, can you? And I ain't seen no holes in the earth with space seen through them, so, no, it can't be flat, sorry. Look down the nose.
I mean, really, for these, actually, I think we're probably not using sea level, but we're using the WGS 84.
Oh, yeah, and what's that one? So,
Isn't sea level curved, though?
Yes.
obviously.
So if you're not measuring from a flat horizontal, how are you getting the correct height?
Well, because locally it is a flat horizontal.
Curving there, right?
Well, it can be concave and convex.
Not locally, is it? You can, to us locally, it's flat enough to be considered flat.
Yeah, but let's say the base of Everest, that would be on curvature. That big.
Yes,
So that'd be
that's true.
attached to the bloody earth.
But if it's not level, how are they measuring it then? Which are they measuring it from the center, from the edge? Where from?
Well, ultimately, you measure from sea level.
But that's
Bloody
curving.
surface.
That's curving. So where's the apex of that curve, of that level?
But you're conflating curvature with elevation.
No. I'm talking about sea level, like you're saying. You measure from sea level. But that sea level is curving.
Yeah.
So which bit of the ground are they taking their measurements from? The middle, sides? All of it's not flat, is it, underneath the mountain?
You're sounding a little like Demok.
Yeah. Say dirt. Say dirt a lot.
When two tectonic plates smash together, they create a fucking mountain. Tectonic plates are on the surface of this planet. Get it?
When they do these, when they do these surveys, they start at the coastline. They get an average sea level at the coastline, and that is the starting point for the survey. And then they work their way inland from that level.
Yeah, but again,
if you look at the picture that I just posted, it'll show you that Everest is in fact measured from the base of the mountain and not sea level. And if they weren't measuring from sea
nonsense.
level,
I don't believe that. That's absolute nonsense.
well, this one's showing that if they measured from sea level, then Kilimanjaro in Africa would be the tallest mountain.
Actually, in Canada.
No, it's not. This is showing you that if you measured it from the base, that would be true. It's showing you the opposite of what you're saying.
Okay, let me look.
Because if you look, it says that Everest is 5,200 meters from the base, but Everest is 8,848 meters high.
From sea level.
Right.
So, yeah, you get different levels there. Sea level and fucking base level are different.
Okay, so this graph isn't actually
Let's say
showing.
you remove
And
the
this-
water. If
and-
you remove the
And
water,
then you've got a mountain that's under the sea,
Aye.
which is called what's that? Mauna Kea. That's got to be Hawaii or somewhere, hasn't it?
yeah, but if
So
you
let's
remove
see
the water,
how
which, is,
high Mauna Kea is above sea level.
which would be the tallest mountain if you took away the water? Just
Okay,
land.
so,
Everest.
Everest, yeah, so.
So it's 4,207 meters above sea level. It says here.
That's bloody high.
And yet in here it's 102,000 meters.
Depending on where you stood, yeah.
So thank you for proving my point, Hank.
And amazingly, it's very difficult to breathe at the top. What a surprise.
Well, yeah, altitude can
That's
do that
true.
to you.
You guys are surprised by that?
But I still
Well,
can't see how
we're
they're
not, but
measuring
you should be.
if it's curved, Jem. Why say it's level if it's curved?
Well, because you have sea level all around the Earth, right?
Always
70
the same distance. to the middle of the
72% of the Earth's surface is ocean. It's all at zero, and it's all curving.
No, that's what I'm saying. If it's all curving, which part are they measuring from?
Well, I hope it's all
Well,
same.
it
It's
depends.
pretty much
Depends what you're measuring. If you're doing a survey, like a geodetic survey, like I say, you take an average.
Split the difference.
To
There
get
you
a
go.
sea level, and they start from that point, that level, whatever that is.
It's a local measurement.
It's around. It's about under your foot around there.
I think they do an average of high tides, actually.
What, over a year or a month?
Yeah,
or...
I think they do the average of high tides over a year.
Cool.
It's probably
So
time for me to
you're saying
unbox
you can
Shroom.
have a plane locally of sea level, and then it slopes down a meter.
Well, yeah, and then that'd be the ocean floor, wouldn't it? You know, get.
Well, look, think about it this way. We're saying that about the ocean, and you realise this already, don't you?
What, that it slopes?
That it curves away from you.
So that's
And
what
just
we're
drop
doing.
off. It doesn't just-
And
Sorry, go on.
right. So you understand that we're saying that the ocean curves away from you at any given point, and we're also saying that the elevation that remains zero.
Yeah, but that's the point. Is for 4,000.
Right. So then any object on top of that, you measure from zero, don't you? From that zero. At any point on the Earth.
Yes,
You
but
don't measure
Hank
from
is
the top
saying
of the
that
bloody object. Come on.
you're never
Oh,
measuring
God,
a
this
curve.
is-
You're just measuring a slope. That
This is
elevation
like
drop.
teaching my granddad to play
It could
Monopoly.
be a
at
vertical
Christmas.
drop.
That elevation drop is not a curve. It's a slope, just like going downhill.
Some are slope, some aren't.
Right, well, that
Some
has
is vertical.
nothing to do with elevation.
No.
That is what
Curvature
it is.
is not elevation.
You're on top of a mountain, bottom of a mountain, you're at different elevations. You would slope down the
Yeah.
mountain.
Yeah, and that's not curvature, that's the mountain.
Exactly, and the same thing happens on the ground. It goes down just for a meter, and then flat, and then up a meter, and then flat. No curvature, like actual measured curvature.
Yeah, those are pretty fucking like, you know, rocky.
Well, that's your assertion, Chemo, but, you know.
And that's what the
just
paper
an
says.
assertion.
That's what the paper Hank's bringing. Saying those salt flats are flat. And then after...
You're trying to reverse this, Chemo. No, you can't. Don't do
It's
that.
telling you how much they rise above sea level.
You can't do it. Stop trying to bend it.
So if
You're
it's
trying to
rising...
Sea level is curved.
Somebody's projecting. Chemo, stop trying to bend the salt flat.
Exactly. He's trying to bend some of this flat.
It is bent.
Well, yeah, it is. Yeah, sorry. He's trying to flatten some out with bend. That's right, yeah.
It says it's the largest salt flat on Earth.
Well, yeah, but it's curved. It has to be. Because it goes over the fucking curve.
Right.
But it's as flat as we can see it.
What does that mean? What does that mean? It goes over the curve. Where does it say it goes over the curve? That's assuming the Earth is.
That's physical. That's just a physical fucking entity of the question, isn't it? We already we'd have to assume that.
Let's drop the assumptions and go with what we actually know. Right? You can't just assume they mean curve.
Well, no, we know what we see, what we measure.
If he says vertical, vertical is not curved, is it? You have a horizontal and then you have a vertical. What's difficult? What's difficult?
It's not straight. Well, that bends, but it looks straight. There you go.
You know the difference between vertical, horizontal, and curved?
Yeah, everything looks like it's supposed to do, but outside factors could make it behave and look differently. You know? Even though it's the same, it can look differently, but it'll still be the same, you know? Just because it's a curve, it doesn't necessarily mean it's a curve. It could be a straight line that is curving. See what I mean?
That's the thing, Tal. It's just a story. And, you know, you're just adding to the story.
From a point of perspective.
Yeah, it's like we're around a campfire and you're just adding to the story now.
No, not so much adding to it, crossing the I's and dotting the T's.
Yeah, adding the story, making sure the story is interesting. But it can be broken down easily when we ask for a practical measurement of curvature. When we have a practical measurement of flatness. The difference.
Well, yeah, but you see, you have a practical measurement of flat where you made it flat. But the actual measurement is curved. It's what it is. You know, we make areas flat so that buildings don't fall over. Right. You know, it'd be pointless building a fucking building at 45 degrees, would it? You know, it'd be daft thing to do. So, you know, wherever we see curve it.
Do you think the salt flats used to be a mountain, made it flat?
Well, there used to be an ocean bed.
Just salt.
The salt flats are a seabed that's dried up thousands and thousands of years ago and left the salt behind.
Before we get too far away, Hank, you were talking about if P then Q. That's how this started, and somehow we got away from if P then Q.
Yeah, no, they prefer to talk about mountains.
Sorry for bending it away from that.
Talk about if P then Q and how you ignored refraction. You talk about that? I don't care.
Yeah, I'm sure.
So can I get you guys just to admit that if there is refraction involved, and the Earth is actually bending with the black swan and all these other black swans that allegedly exist, according to you guys, then that means that the light would be bending at the same curvature as the Earth. Is that true?
Well, no, not necessarily.
So if there's a laser and it hits the target 20-something miles away, it didn't bend around the Earth curve.
Yes.
Yeah, you have something called the Doppler
effect. It doesn't have to be perfectly with the Earth.
Right, but the ray...
It could be a slightly different curve to the curve of the Earth, and you'd still be able to see it.
The laser the laser is bending around the curve of the Earth.
Yeah.
And it's hitting the target.
Right.
I believe one example was like 4 feet above.
Well, no, I to be honest with you, I don't think that's probably not happening in those. Well, I mean, it is. It is going to be happening to some degree, but it's difficult to tell because most of these laser things, you don't hit a target, do you? You just have somebody stood on the other side of the lake or whatever saying, yes, I can see it. And then now you've got a whole load of other factors at play, namely and mostly the spread of the laser beam over that distance.
Yeah, that's what I was going to come to. That point that lasers over distance create something called the Doppler effect, and the beam gets wider as it gets further away from its target. Well, further away from its origin. Sorry. So
what was it like?
Yeah, I don't think that's a Doppler effect.
I thought that was a conspiracy theory. Sorry, is that atmospheric magnification? I know it ain't the Doppler effect.
No, it's called collimation, and that's the ability of a laser beam to maintain consistency over distance.
Okay, because it wants to spread out, right?
Right. I mean, we know that a beam would do that. The problem is when you've got someone with a video camera on the other side of a lake who says, yes, I can see it, you don't know which bit of it he's seeing.
Right. So when you look at Chicago from across the lake, those, you're not actually seeing Chicago, you're seeing the light reflect off the building. Would that light, let me finish. Would that light expand in all directions, including down towards the water?
A reflection, yeah. If the water was still enough, you'd see a reflection going down, yeah. And it
You mean would the light rays spread out like they do from a torch or a laser beam?
Yeah, over a great distance of water. Yeah.
No.
So the light wouldn't interact with the particles from the evaporation from the lake and bump into them and slightly spread out and diverge in all directions as it's traveling over 50 miles.
You can get that as an effect to some degree, right?
Right. So that's
right? Hold on. Scattering is not divergence.
Right.
Scattering is separate from divergence.
Okay. So
and also, here's another big point. Light emitted from the light source is not the same in respect to pathway as reflected light, which is going to be reflected at all kinds of angles of incidence.
Thank you for that voice of reason, Cat.
And how you normally employ things like the Doppler effect to look at things like redshift, blue shift.
Oh yeah, no, my bad. This is the thing with me. I have all the information there, but it's all fucked up in the wrong order. And I seem to come out with things that are similar to what I'm talking about, but they're not. There's fuck all to do with them. It's annoying. I think it's the drugs. I blame the drugs.
Are you going on a rant again?
No, not this morning. I'm going to leave it.
Kyle, look. Kyle, explain to me the refraction then that happens. If P then Q, how do we include a refraction?
How do we include it?
Yeah.
It's really negligible.
We use 7/6, don't we, as a standard? That's a quick, short way to get us there.
Yeah.
But the problem is, though, that I think that you have really two choices with this. And normally you opt for choice one, which is to either pretend there's no such thing as refraction or pretend it's some,
where did you get the from, Jem?
Misunderstood thing that we don't know what it is.
I know you don't like that question, but where did the R come from?
Or that your other alternative is to actually take measurements of things like the atmosphere, so that when we say, haha, that's refraction, you can then say, haha, no, it's not, because we've got these measurements of the temperature and the water and the water temperature and the air pressure and all of the factors that go into the what they call it, refraction coefficient. So that's the problem with these things. You guys will say it's not refraction, but rarely do you have the required data to be able to say that.
Well, I just posted something called beam divergence from Wikipedia, and it clearly says that the beam diameter or radius distance from In electromagnetics, especially in optics, beam divergence is an angular measure of the increase of the beam diameter or radius. Isn't that what I just got through talking about? I was told that was incorrect.
Yeah, that's correct.
No,
We're
at no
talking about
point.
the meta.
We said that that's what happens with a beam from a torch or a laser, right?
No, he said
that. He introduced that idea that it will do that. I said that.
Well, the other guy piped in and he said that it wasn't divergence.
Hold on, Hank. What did I say wasn't divergence?
Right.
Light scattering. You said it was scattering, not
Correct.
divergence.
Yeah.
Scattering is not divergence. And you posted an answer from some apparently Russian guy, I think, that immediately went into talking about dispersion, not divergence.
I was talking about divergence. You brought up dispersion.
I never said dispersion until this moment.
Really?
Really?
Yeah, he said scattering.
Okay, scattering. Okay.
Well, think about it, Hank. Think about it this way. If you had a flashlight, right, and you were standing, I don't know, at one end of the largest room in your house, and you turn the flashlight on, you are going to be able to see that beam getting bigger as it goes across the room, right?
Yeah.
You will see the beam widening. And yet you could turn your lights on and look at the wall at the other end of the room.
Right.
The wall doesn't shrink as you get closer to it, does it?
Right. So if you take that flashlight and lay it on the ground, some of the bottom of the flashlight, the light is going to get cut off, and it's not going to be a full circle on the wall if it's far enough away.
Where you can browse.
And I'm saying that the same thing happens with the image of Chicago as the light travels over a great distance,
in a
like 50
plane
miles,
that are a given distance
and this is not
from a
curvature
given
cutting
point
off the
in
bottom
the plane.
of the city, that it's divergence cutting off the bottom of the city. Because think about it, should you be able to see a building from 50 miles away? Obviously, the image is stretching for you to be able to see a building from 50 miles away.
Why is it obviously stretching? Why? Well, how have you concluded that? Just because it's 50 miles and you have arbitrarily decided that an arbitrarily sized building shouldn't be seen from 50 miles?
Well, if you look at the video, Rob Skiba took a boat over there and back, and he took a picture of the city up close, of the building that he was looking at up close, and then he went back to the other side and took a picture again, and they appeared to be the exact same size from the exact same zoom setting. Now, we know that things get smaller as they go away, don't they?
Hold on a minute. What are you saying? Well, I don't believe that. I think that's nonsense.
You don't think
So you're presenting this...
Hang on. And what does they appear to be the same size mean? Does that mean you and Rob Skiba guessed that they were the same size, or was there some measurement made?
No, there wasn't no guessing. He takes the picture and puts it up side by side, one from in the city and one from 50 miles away. And they're side by side on the screen, and they look like they're the same size, but he's 50 miles away.
Right, because he's zoomed in.
No,
he said they look like.
That's the thing. He didn't zoom in.
That cannot be true.
That's nonsense.
Okay,
You're talking about the guy.
Is atmospheric magnification a real thing?
Or maybe he didn't zoom in, but then he cropped and enlarged the photograph. That's another possibility. To make it the same size.
Rob Skiba is sketchy at first.
But saying it appears the same size when you're next to it and 50 miles away is, complete nonsense.
At 50 miles away, he's not going to see it if he didn't zoom in. It's not going to be in the picture.
Just using the word appear and looks like, it's just hopeless language for science.
Right.
Yeah.
Evidence.
But the thing is,
all a bit wishy-washy is.
You guys got any science?
Well, actually, here's the thing. Rob Skiba lied about using a Fresnel lens and the fact that he didn't have it centered in the camera and used that as evidence of the flat Earth. How do we trust him?
What does the lens have to do with anything? I thought he was using
because he used it to manipulate the image.
How does that manipulate?
We don't need to trust Skiba here. We know for a fact that they're not the same zoom. Up close to the city,
I might
50
be
miles
wrong.
away, that's not the case. Either somebody is misrepresenting or has, confused something, but that's not the case.
Yeah, that's possible because I haven't done extensive research on this like you guys have. What does it do with the lens? What does the lens do exactly?
Oh,
It
come
meant-
on. If I
That's
had
a
a
different
penny,
thing.
if I had a penny for every time a flat earther says, "Oh, it's the lens that's doing this," I'd be a multimillionaire.
Lenses bend light. There you go.
Yeah.
What Davros brought up was a different video of Rob Skeeber's, but it just shows that it just sort of talks about his trustworthy and how little
I think
trustworthiness and how small that should be. How
Okay, so do
not
lights.
trustworthy he is.
especially when you're kind of practicing science. I mean, it's one of the things that in science will get you blackballed if you're caught lying, falsifying your data. It's hard as a scientist to come back from that and work in your field.
You'd be fucked.
Is the science from the Imperial College scientist who made that model? Is he blackballed?
James Clerk Maxwell. Cavendish. Aristophanes.
Sorry, mate. Say that again.
Space. Not even an experiment, it's an observation.
Well, we've got. Is an observation good enough for you?
Yeah, an observation. Better than an experiment.
Cavendish. Well, it doesn't prove you're on a globe, but it does show gravity. Mass attracting mass.
does the same. Yep.
Can you present any independently assessed evidence of a flat Earth?
Yeah, he ignored that question.
Yeah,
No,
no, you
I
answer the
didn't say I
question,
did.
Chemo.
Hey,
Yes, it
Chemo,
has.
you're here all day. Why are you deflecting and taking time from Hank? Yeah.
Curve's coming through loud and clear, mate.
Yeah, you have. Have you fixed it then, Curve?
Don't know.
You seem
You
to
actually
have.
sound really good. What the
I
fuck?
noticed yesterday I didn't hear it crackle.
Well, Discord just did a bunch of updates that may have fixed that, but screwed other stuff up. Dav and I were having problems watching streams off each other's stuff
Yeah,
earlier.
there was JavaScript errors.
Yeah. So they
Well,
fixed
stop
one thing,
webcamming
screwed
each
another.
other on Discord. You know.
No,
It's
it was
bound to-
stream. It was streaming YouTube.
You were-
It was, yeah.
Watching
You
each
see,
other
Jim, it's not all
masturbate is not
Australian.
No,
what
no, no,
the
watching a-
platform was designed for.
Hang on, Jem. I'm just going to turn on your webcam. Hang on a sec, mate.
Hold on, can I interrupt real fast? I just wanted to interrupt.
Yes, I actually can. Sly Sparkane did one with about 20-something people around the world.
Oh yeah.
I just want to say this real fast. Just a few minutes ago, Jim, I believe you said that you don't know which part of the laser is actually hitting the target, right? Because of the laser.
No, I said normally with these tests they don't hit a target, and it's just somebody on the other side of the lake saying they can see the laser, and they don't know which bit of the laser they're seeing.
Right, because it expands out like a cone, like it diverges in all directions.
Yeah.
Well, right here, Metabunk is saying that atmospheric magnification has been debunked. So isn't that like the same thing? Because if the atmosphere is causing, let me finish, please. If the atmosphere is causing the laser beam to spread out, wouldn't it also cause magnification if you're looking at an object? Like
the
from 50 miles away?
The atmosphere isn't causing it to spread out, though.
What
That's
is?
it. I don't really know. I'm not really sure what the physics.
Similar, but it changes the
A
effect.
laser will diverge in a vacuum. A laser will diverge in a vacuum. I'll
Right.
repeat that one more time. A laser will diverge in a vacuum. No, because it's not atmosphere that causes it to diverge. Atmosphere has
Well, there's
other
no
effects.
perfect.
Divergence is not one.
Right.
There's no perfect vacuum, so we don't know. It's like saying what would happen in an isolated system.
It's not
We don't know.
magnification from the atmosphere. So that was incorrect, Hank. We can't. Do you want us to lie to you and say, "Oh yeah, that is magnification"? No, that's not magnification.
Again, how could it be? Because if it was the atmosphere, your wall would look bigger when you're a bit of a distance away from it in your house, wouldn't it? And it would get smaller as you got close to it. Well, according to Hank, it does. He says that the beam of his flashlight is spreading out, so the light reflected off the wall must be spreading out equally. And therefore, if the beam of his flashlight is larger at a distance, then the wall of his room would be. I mean, we know that that's not the case. It's silly. No, it doesn't.
Timo, are you just saying words to get involved in the conversation? Because you've just these little bits and bobs, and it
I
meant
think he's
nothing.
saying anything he can to rescue Hank from the holes that he keeps digging himself.
Black Swan's dead.
Hang on, whoa, Kima, did you just bring in temperature inversion? Welcome to the globe, buddy. Good job. That's what caused it, you dick.
No, it's not.
Ooh, you sound deflated, Chemo.
I'm
Poor
sorry,
Kimo.
but this is what I find funny. The one thing that these guys denied for 6 fucking months was the temperature inversion, which caused the wibbly wobbliness of the towers.
And now all of a sudden,
and he just admitted it.
I think there's an important follow-on question here for Chemo. Chemo, would you like leg or breast of your roasted swan?
Oh dear.
Anyway,
Can't
back to
answer Chemo, you poor thing.
God,
Anyway,
all of the, he sounds so deflated.
Anyway,
You know what's good
back
though is
to
that
Hank.
Kimo can still talk with his foot in his mouth.
Kimo, why don't you take some tips from Hank and learn how to be sincerely incorrect rather than deliberately incorrect as you're being at the moment and usually are.
We're actually making a point. Sorry, I zoned out ages ago.
Because he actually believes what he's saying. You, on the other hand, I can't say that about you, Kimo. You're just trying to rile people up with things that you know are.
No.
Anyway,
it is about what you say and how you say it and why you're saying it. That's exactly what it's about. I'd much rather answer Hank's questions than yours because you're not sincere, Kimo.
Sort of.
Motherfucker, you gonna question my sincerity?
Brought anything to the table. I love that. That's a fucking straw man.
That's a joke on its face. Don't even.
Holy fuck, Chemo, if you make me come in here and defend fucking Curved, you've seriously taken the wrong fucking turn.
look, guys, Hank doesn't come here much. Chemo's here all the time.
Yeah.
Can we let Hank have the microphone?
Hey
for a
guys,
bit?
don't give me special privilege. I mean, I'm just.
You're special, Hank. We have to give you privilege.
Well,
Is it
it's not
because
just
I'm
that.
white? Is it because I'm white?
Are you
No,
white?
no, it's not. No,
I
it's
haven't
not just
seen
that, Hank. We're sick of chemo, honestly.
He opens his mouth, he lies.
Yeah,
We heard it.
tell, though,
So
could
love
you
to
guys?
listen to you.
That was
Love
not
to
my
listen.
sentiment.
Well,
That's not
I've
what
already
I
been
was trying
accused
to
of
say.
lying a couple of times in the voice chat.
We treat chemo more as a chew toy nowadays, I think.
well-known fact that chemotherapy makes you throw up.
But it helps you lose weight.
The best thing I can say about chemo is basically, here he's kind of a necessary evil at times, and that's the best you're going to get. Chemo.
Yeah, but remember, it's not about him. So let's move on.
Oh no, not about chemo at all. No.
The children being lied to.
You know, Hank brought up an interesting idea about the distant building being cut off by divergence, and I thought that was an interesting take on it. I don't understand why he thinks that, but maybe we could explore that a little more and see if that's actually a possibility, or if there's another cause.
Well, is there anything that could cause a false horizon?
A false horizon?
You know, a horizon that's not geometric. Is there anything that could cause a horizon other than
refraction?
Okay. So light does bend, right?
Okay, let me add refraction and like topography, elevations that do not conform to the geometric ideal sphere. Those would be slight changes from in affecting the distance to the horizon and such as well, or the location of the horizon, obviously. You know, because I mean, the mathematical formula that you're talking about for the geometric horizon, you're basically using an ideal sphere for that without refraction. So yeah, sure, there's things that change that. So go.
You know, honestly, I'm still trying to find where the atmosphere causes it to diverge. Because it just seems right.
Does it?
It does.
What would be? Think about what the effect of that would be. Things would be
stretching the
bigger.
image.
Things would be bigger as you got further away from them.
But then it would be cross-canceled at the same time because things get smaller as you go away from them.
So according to you, then things don't change size as you move further away or closer to.
Well, no, cross-cancel doesn't mean it's perfectly taken out. It just means that it's countering it in the opposite direction.
Okay. So how could you establish that?
Well, I've experienced it. I've experienced it in everyday life.
You've experienced things getting smaller as you move away from them, but you're saying they're also getting larger as you move away from them, just not at the same rate as they're getting smaller.
Especially lights underwater. I've spent a lot of time.
So how do you know that they're also getting larger? How do you know that they're not just getting smaller as you move away from them?
Because I used to get really high and sit at the bottom of the pool for as long as possible. And I could tell that the light isn't actually that big. Because when I got closer to the light inside of the pool, it was only the size of my hand, which is, relatively 7 inches or 8 inches, something like that, right?
But now you're talking about how light behaves in water.
Right, it's the fluid, right? Just like the atmosphere.
Well, it's not the atmosphere, though, is it?
It's not as dense as the atmosphere, but it makes a pretty good model for what atmosphere does to light.
Well, what do you think makes the best model of the atmosphere? A swimming pool, or the atmosphere?
I didn't say it was the best.
Is this your experience in the atmosphere? If you see this, if you were to drain the water from the pool, would
think about it, bro. When it's foggy, doesn't?
Well, no, you think about it. If you drained the water from the pool, would the same thing happen?
No.
Right. I rest my case.
Not as much.
This is not a model for the atmosphere.
Okay, so think about
because when you have the water there, it's completely different to what happens in the atmosphere. That tells you it's not a model for the atmosphere.
Okay, so think about when you see a tower, right? And it's a crystal clear night.
Right.
Like the light looks really small. But when it's a foggy night and you see the light at the top of a tower, the light looks really big, does it not?
Right, but that's
Scattering.
That's the light reflecting off the fog, right?
Right. Light does interact with particles, right?
And you don't see the light. You do only see the scattering of the light. That makes it bigger.
Yeah, it makes
you
it
don't
appear
really
to be
see the
bigger.
light, the lamp light source.
Look, I say, as you move away from things, due to perspective, they look smaller. You're saying that's true, but they're also getting bigger because the light is spreading out.
They appear to get bigger.
Right. So how can you determine that, though? How do you know that they? Because you're saying that they still get smaller.
Well, what about an arc welder? You ever seen an arc welder up close without the protection? Because it's a very small little arc, but it looks like a really big light, doesn't it?
Getting all divergent again, aren't you?
Again, though, if I accept that this is true, how can you establish it and at what rate it's occurring?
I don't know. I guess I'd have to do some research.
Because I think things always get smaller at the same rate as you move away from them. I think that is calculable. But you're saying it's not. You're saying that this varies according to the atmosphere.
Well, I would think that there would be factors that would factor into this, causing it to change. And the atmosphere would be the medium in which something is traveling through, would be one of those things. For example, the speed of light changes as it goes through glass. It slows down, and then after it passes through the glass, it speeds back up again.
Right.
So if it can change the speed of the light, is it possible that it could slightly change the direction? That's refraction, right? So we know that it changes direction, but is it possible that it changes in all directions at the same time? That's scattering, right? And if it changes in all directions at the same time, wouldn't it cause objects... Sorry, my cat. There was video game cases. Wouldn't it be possible that everything that's scattering would cause a light to appear larger than it actually is?
Well, again, how can you establish this?
Well, I've experienced it.
Right, all right. Well, I just believe you then, hey? If you say that's true, it's got to be true.
Well, think about like square lights, like working on a car. When you get really far away, they look round, but you know it's a square
Look, you
light.
can keep giving me examples of where you believe this is true, but how can you establish it to be true?
Well, I guess I'm going to have to figure out what the scientists call it, and then when I show it to you, you'll believe it. Let's see. Let me look it up.
Hang on. So you're telling us just because the lights on a car is square, you can't have a round reflection?
Did I say that?
Well, that's what's pushing the light out, is the reflection of the globe off the mirrors at the back.
No, I said when you get further away, square lights look circular or spherical.
Yeah, because that's the way the mirrors are designed.
Can I step in here for a second? Hank, you're operating with a fundamentally flawed understanding of optics, I think, because you're talking about light diffracting outwards, right? All that light that diffracts outwards, you don't see. You get that, right? Unless those photons are hitting your eye, you're not going to see them. So unless something's taking those photons that are going outwards and refracting them back into your eye, you're not going to see all those photons that are going out. Hello?
Yeah, I understand that. Of course, if they're not your eye, you're not going to see them.
Yeah. And so what you're describing is something, the phenomenon you're talking about, there has to be something about the atmosphere which takes them outwards and then turns them back around to hit you in the eye. And that's a lens. Only a lens will do that. Atmosphere can't lens. It's not shaped right.
Does the atmosphere have a shape?
No, exactly. It doesn't. That's why it can't lens.
All right, give me just a second. I'm reading something, please.
All right.
And technically, the atmosphere is a liquid.
No, it's a fluid.
No, it's a fluid, not a liquid.
Well, I meant a fluid, sorry. I misspoke. My bad.
We all do at time to time.
But I was spot on with the AMD, so I'm happy about that.
Oh, you mean you were spot on about the stuff that Moore's law is dead said like 2 months ago?
Actually, I said it way more than 2 months ago.
And does that mean you have to go out and buy one?
No.
Right, then we'll leave it there.
But if Intel wants to go clock for clock with AMD, they'll have to clock their CPU at 6.35 gigahertz.
Yeah, they've basically been bent over, mate.
They'd be ruffle stomped.
Yeah, well, they wouldn't change their die size, so yeah, dumbasses.
Well, I think that's what happens when sales critters and market droids take over. Yeah, and they push the engineers to the side. But it happened to IBM in the 1980s. So if you read the book from Sean Carroll, IBM, Big Blues, The Unmaking of IBM, then, no, not Sean Carroll. Damn. I hate myself. Carroll's his second name. I think it's Paul Carroll.
Oh, you're talking about the ex-IBM exec?
And?
The ex-IBM exec that ended up moving over to Intel, I think it was, wrote that book.
No. He was a journalist. He basically reported on IBM through the 1980s, and he wrote the book in 1993.
You know they're re-releasing that keyboard from fucking 30 years ago.
That weird bendy one.
No, the original IBM keyboard with the big clunky keys.
Yeah, no, they've been out for donkeys.
Yeah, but they're remaking them.
No, they've been making them for ages. It's just a different company.
No, they're remaking it. They're redesigning it.
Okay.
But it's still got to be the same shape.
Oh my God.
Yeah.
And can I point out that we are in idle time chit chat at the moment?
That's okay. We were waiting for Hank to read something.
Yeah.
Yeah, sorry about that. You guys go ahead.
That's all right, mate.
Well, I been reading this. I guess I'll share it with you guys.
So we didn't want to disturb your reading, Hank. Sorry, man.
Oh no, you guys didn't disturb it at all. I just can't find what I'm looking for, but I decided to share it anyway.
I'm sorry, I'm being a cunt. That's not new in here.
Cool. I like astronomy. So, and this says what?
It's a big purple light. I don't know.
Objects appear larger than they actually are, is what it says. But I can't figure out why, so they didn't say why.
Refraction could be something to do with it.
Yeah, there's
Maybe
huge.
It's a Big Bang.
Yeah, the atmosphere that we look through.
Big refractive fucking mirror of death.
Why is it 13.7 billion light years? It was 13.8 5 years ago. Is the universe getting younger?
Actually,
expanding.
Is it like BC? Are we counting down?
As our measurements get more refined, then obviously the estimations also become.
What measurements are you comparing?
So the last sentence, in this instance at least, you might say the universe is much, much, much smaller than it appears. But it never.
From whose perspective, you know?
Wow, you know.
Fucking gods.
Yeah, what did they mean when they said that? What were they talking about? What kind
Objects appear larger in the sky than they actually are.
Well, yeah, that'll be the refraction effect. It splits the light and makes the object just look bigger than it is. It's not really new, you know. It's just like, one of them things.
But you guys said that doesn't happen.
Well, it doesn't happen physically. It happens illusionary.
Yeah, I never claimed that they actually get bigger. I don't think the lights are growing in the swimming pool. As I'm moving back and forth, they're growing and shrinking.
How do you know? It could be a remote control light in a swimming pool. Behave.
If you're looking to the moon, sometimes you see a big moon, and when you hold your thumb near close to the moon, you see the moon shrinking in the moment.
Mm-hmm.
It's a very interesting effect.
I was thinking of exactly that just as you said it.
Eye has no comparison. You see the moon in the sky, it's bright, it has to be big. And so if you hold your sun in nearby, close by, you see the moon shrinks in this moment.
Oh dear. I'm sorry, but I've just read the bit that you're omitting here. If you could view the full extent of the Andromeda Galaxy, it would appear shockingly large in the sky. The galaxy's disk appears as a fuzzy smudge about 1/4 of a degree wide to the naked eye. But with larger telescopes, you'll find it's about 3 degrees across. Oh, interesting that.
So the galaxy appears smaller than it actually is.
Yeah, but if you use better equipment, you get the actual size.
Yeah. Lensing effects.
Well, what's causing these lenses? These lensing effects if space is a vacuum.
Well, light changes direction through gravity, doesn't it? So it bends all over the fucking place. It's a dispersion pattern. It scatters.
That's the characteristic of the light itself. In fact, the red and blue shift is part of that, and we pick up whether it's moving away from us or towards us by the red and blue shift, which comes from a slight
light is all around,
diffraction, whatever you call it.
Apart from this.
Sorry, I hate this vacuum shit.
Yeah, I know. It just get in the way, doesn't it? It sucks, doesn't it, mate? I tell you.
I'm over here snickering.
This is like.
Well, tell me, why do you hate the vacuum shit? How does the vacuum
because
shit?
You guys
make
think
you
it's the perfect vacuum, but we can't have one. And
I've
we've
never heard a
said there's
flat earther say that.
Holy
We
fuck!
all know.
Witsit said it like 3 fucking times
It's
yesterday.
not a perfect vacuum.
No, it's not exactly because there is
17
stuff
torr.
in it. Yeah,
Yeah.
10 to the
Sorry,
negative 17 torr.
So-
Right, so 17 zeros and a 1, so it's still positive. It's just less pressure than we have down here.
Yeah, but if
That's all it
you
is.
round up or round down, what does it round down to?
It doesn't.
It doesn't. You don't know how to round down? See, what you do is you take the point and then you round to the largest number on the
Then
left
it'd
side.
be 1.
No, actually, it'd be
Yeah, it's
0.
weird. It's
Why
weird,
would you do that?
it's weird though that when you use a
Why
telescope,
would you?
Andromeda appears larger, and yet when the sun disappears at night on a flat Earth, no amount of fucking telescope's going to bring it back.
Well, of course not.
Weird.
Bendy one. You look around corners, well.
Yeah, weird that.
Also, the vacuum of space is not a vacuum cleaner.
Well, you know. It might be.
Really?
It sucks.
Seriously?
Really? Yeah,
I thought
it's not a
Hoover up
vacuum
there
cleaner.
was
No.
building telescopes.
So if you're on the ISS, if you're on the ISS, you're in a pressurized vehicle. It's not the vacuum of space sucking the pressure out. If you were to get a hole in the ISS,
You mean the pressure
it would
pushes out? Like
the
it's
pressure pushes out from the
expanding
container
out?
itself into the vacuum of space. It doesn't get sucked out by the vacuum of space. No.
That's new to me. I didn't know that. I thought there was literally vacuums up there, like wet vacs and dry vacs and shop vacs.
Well, that seems to be something that, you know, we constantly have to say. It's not a vacuum cleaner.
Who do you have to say this to?
Flat earthers.
You gotta be kidding me, bro.
Yep.
So they think there's vacuums in space, like Hoover.
They think, well, no, they think the vacuum of space operate. Yeah, they think that like the emptiness of space sucks things into it, not the other way around.
What about like normies that believe in the globe? Do they think the same thing?
The
Shouldn't fucking Morag. Listen, shouldn't fucking Morag. Are you from fucking Neighbors or something? You from fucking Neighbors?
So what about the normies that believe the Earth's a globe? Do they think that vacuums suck?
Fucking Morag.
No, Hank. It's not normies. It's called the reality-based community.
There's probably quite a lot of
figured you would
people
understand what I was talking about.
Probably quite a lot of people think that. Yes.
But as a general rule, people do believe vacuums suck, even people that are on the globe side.
Yep.
Because they see science fiction movies, and that's what appears to happen in a science fiction movie.
Yeah. Look, End of Aliens is a perfect example when Ripley's trying to, you know, get back into the ship. If that had happened, the atmosphere in the ship would have been sucked straight out, just about. Like, it wouldn't happen like that.
Instantaneously.
It wouldn't constantly suck it out like that. It would be instant.
Gone.
Yeah.
It would take a while.
Velocity involved would almost.
Yeah, I
try
think
to,
it would take a while. Maybe not that while.
Yeah, not as long as she spent trying to get back in. Yeah.
So I got something for you guys. Posting it in the chat. Apparently, you didn't understand what normie meant. So there's a definition for you guys. An ordinary or conventional person as distinguished from someone who is a member of a particular group or subculture. So when I say normie, I mean someone who's not involved in like the flat earth debate on either side.
But Hank, you know the problem with the word normie is that there's literally no normie in the entire world. Like nobody's a normie. Everybody has some geek or interest in something unusual.
Yep. Yeah. Defining normal is a difficult thing to do.
Well, no, they're not normal. They're normies. Right? Normie has a different meaning than normal. So, as distinguished from someone who is a member of a particular group or subculture. So, in order to say this, you would have to say that every single person is part of every single group or subculture. So, Flat Earth is a subculture. Thank you, I appreciate that. Flat Earth is a subculture, like you guys are in the Flat Earth subculture. Right?
So Hank, from now on, we call you Abe.
Now we're a little more off the rails.
As in Abe.
Yeah, I agree with Woz.
We've just been put into a subculture of people who fight against the flat Earth. Therefore, we are not normies.
Yeah, that's true.
Yeah, I call you guys globies. You guys are globies.
I think that's called deflection. Deflection away from the initial fact of light refraction.
That makes us fucking subnormal.
Okay, that's.
Okay, it appears you guys are right. I had some serious trouble finding the laser makes the divergence. The atmosphere makes the laser diverge. Couldn't find that one.
I'll just look up divergence field for lasers.
Right, but I did find a website that said that. Let's see, what's the title? If this isn't a clickbait title, because I don't know. Objects in the cosmos are larger than they appear.
Yeah, it is. It's misrepresenting what's actually written in the article. Because it's saying that with better equipment, things actually look larger because they're able to resolve it better compared to what you see. Yeah.
Our eyes are not better equipment, right?
But we will never get a 100% to 100% match because of our eyes and because of everything else. So what we do is we can make an approximation of the whatever it is.
Hank, I read it.
In comparison,
sorry. Go ahead.
Well, in comparison to the rest of the, quite a bit of the animal kingdom, the Mark I human eyeball isn't all that great.
Go ahead, Kurt.
Michael, can we get back to the
Now
topic?
Hank, where in that article does
You
it
read the
say it
article?
made it appear larger to your eye than it really is?
didn't say it to the eye, but I'm assuming that people use their eyes to look at the cosmos sometimes.
Okay, but given the fact that they specifically said, like when they were talking about the Andromeda Galaxy, and like it's fuck, I forgot the term that they used for it, but like all of it, it's halo. Okay, they're talking about how large the halo is around it, and even with Earth's biggest telescopes, they couldn't see it, but they were able to make this determination by viewing other stars and things that kind of like shine through it, and they determined how large this halo was compared to the galaxy itself. But this is not a visual effect. It's not due to magnification of anything. It's actually what is larger is what we don't see. That's something that they're talking about. Something we don't see. Not atmospheric magnification or any other such magnification in any way, shape, or form. I'm lost as to how you came to the conclusions you.
Actually, I didn't come to the conclusion. I said if this is not clickbait, which meant that I still wasn't sure.
No, but even that, you're reading it backwards. But what you just read means we see them smaller, so they're not being magnified.
Well, what about this
They're
at the
being
bottom?
shrunk.
But wait, there is another inescapable cosmic structure that completely surrounds us. The cosmic microwave background. The relic radiation from the Big Bang. So, at least in this instance, the universe is much, much smaller than it appears. So,
No, that's not what it says. It's not
at the bottom, I read it word for word.
Okay, read it again.
In this one instance, at least, you might say the universe is much, much, much smaller than it appears.
Yes, but it says this: a very small and a very large become one and the same. Radiation is everywhere because every part of space around you, including that part where you happen to be right now, was once part of the Big Bang. They're saying that image they've taken is only a small section of the universe that they could take a picture of.
Yeah, and also you don't see cosmic background radiation.
Okay, point taken. You're correct. So, what's the dating method for light?
See it in real time. We can't see the actual radiation in real time because what we're seeing is what gets back to us. So if we see
can't see it
7
at
billion
all.
light years away, we see more.
It's not visible.
Yes, we understand that. It's taking the image, okay? The amount of time it takes to take that image, that's actually probably either moved further away or closer to us, certain parts of that radiation. So, yeah. They have to take that shot every year and check it against the one they took last year and then the one they took the year before to see what's going on.
So I'm at physics.org, and now they're saying the universe is 13.8 billion light years old. So which one is it? 13.7 or 13.8?
Can I blow your mind, Hank? The visible universe that we see is actually about 92 billion light years.
I've seen that video.
Oh,
trillion.
What are we doing?
Well, no, this is the thing. He's conflating numbers, and we'll give him the bigger one.
Well, I don't like inconsistencies. They jump out to me. They like pop off the page.
But you were the
Then how
one just
could you
talking about
possibly
rounding.
think the Earth might be flat.
The Earth might be flat.
Flat Earth is full of inconsistencies, dude. Come on, you got to be honest
What was the
about
standard
that.
model?
Oh,
So-
maybe you are. I mean, you still, after all these years, you have not learned the distinction between curvature and elevation. I heard a bit of that earlier and just was pulling my hair out, Hank. I'm so disappointed. I thought you were past that.
You're pulling your hair out, huh?
He hasn't got any hair, so that's what the real inconsistency is.
So it's shining off his bald scalp. There you go. Refraction.
It's
apparent. How do you not have curvature and elevation? How do you not have that down yet?
Well, if there is curvature on the salt flat, it wouldn't be called flat, would it?
Yeah, in terms of lack of changes in elevation.
And since when is the name
Think
of
of
something
think
proof
of a
or
large
evidence of exactly
sphere,
what it
a
is?
beach ball, let's say. Okay, something you can imagine, you can visualize this. It's not too big for you. All points on the surface of that beach ball sphere, they're all level with each other. Okay, there are no topographical changes in the beach ball. Now, you put indentations in it, and you have put stuff
robots in curved.
He's jumped in the elevator.
Curve, you're roboting.
If he's roboting, there's a good chance you won't
He
hear us.
knows. He knows by now. Usually the
shame.
phones have a 10-to-1 download to upload rate. So as soon as you say roboting, he probably already knew and stopped talking.
Into an elevator with his mic.
Robot me. Why did you fucking robot me?
He's back.
No,
It's a new feature
Actually-
on Discord, man.
Actually, I've got a quick question for the Europeans and the Australians. So we live in these units and we call them flats, and sometimes they're high-rise flats, but they're not flat. So does that change the meaning of flat? Yes, it does.
What, do you got like a hill in the middle of your living room or something?
Can you
No.
can you carry on, Kerr, from where you took off, from where you roboted?
I don't know where I started roboting.
At the start.
Yep.
Okay, Hank, consider a beach ball. All points on the surface of the beach ball are level with each other. Okay? That's you don't have elevation changes going from one point on the ball to the other. You got that? Okay, so in that respect,
symmetrical.
yeah, elevation is flat.
that's a new one. Elevation is flat. Yeah, that's cool. Yeah, it is actually. Depending on which angle you look at it, definitely is flat.
What you have to understand, there's context to everything.
There is.
And trying to pigeonhole semantical arguments for wins, that's not the way to arrive at truth. You have to understand what it is you're dealing with.
Well, you can't even get a fucking answer. How are you supposed to get an answer from that if you're not telling the truth? It's not truth, is it? I get you, yeah. It's not an answer at all. I mean, what's the point in even answering the question? I get you.
Yeah, what's the point of even asking a question?
I know.
How
Weird.
dare you? How dare you ask questions?
Yeah.
You're taking my livelihood, you bastard. That's how I learn things.
Oh my word. We've done him in. We've stole his learning.
So I got a question. What's the dating method for light?
Redshift.
Come in here and go mental.
That's how
Even
you
more
date light?
insane.
You can date light by redshift?
Yeah,
Doppler effect?
CMB like you can, yeah.
Yeah, but this is a conversation that will get very, very complicated if we start bringing in the standard candle that's used to get the approximate distance to another star, and then we trace the light and all that sort of crap, right?
And use triangulation, cosines, and tangents to sell us. I'll break the fucking candle.
Hey Nick, can you elaborate more, please?
Yeah, well, I think the way that they date the CMB light is the way that it basically, as the universe expands, its length changes, and there's a method for working out exactly how old the universe is based on that. I can't remember the specifics. I could probably look them up from my lecture notes from last year.
Nick doesn't sound like he types.
That's because I'm mostly trolling in text chat.
I know. I love it. It's brilliant. That's why I just look at it and go, meh.
How many tablets and like laptops do you guys have?
I take 3 tablets a day, but I've got the 1 laptop. Oh, sorry.
7.
Sorry.
Do you like put them in like a circle and like spin around in your chair all day, like trolling truthers and flat earthers? It's funny.
I'm currently sitting down at my computer, talking through my mic, listening through my headset, watching stuff on a 42-inch screen while posting memes on my Samsung Galaxy S20.
Oh, you doing the alt-right meme war thing?
What do you mean alt-right? I'm a fucking lefty.
and I've got about 630.
Yeah, you gotta fight the other side, right?
Hey, yo, shut up, Davros. I don't even believe your ass. Know what I mean, you smoke crack. Stupid
Oh
ass.
shit! Is that Shroomy?
God, who let out the shroom?
What's up, Shroomy?
Yo, I'm chilling. I mean, I'm trying to.
Here comes some words of wisdom.
Yeah, I got some words of wisdom for Shroomy. The Diaz brothers are making a comeback, bro.
Oh no.
Yo, tell me when and how. I mean, like, is Nick gonna come back and do something?
I think he was suspended for 2 years for the pot thing. I think he's.
Oh, you talking about?
That was like fucking 10 years ago. I mean.
Wait, Hank, you talking about Joe Rogan's mate?